So hello everyone. Now I'll be discussing the 2023 paper 37 question. Starting from the 37 question, there are total 12 questions. Again, the question is association of the magma series along with the plate tectonic settings. Very important topic. Read it out and you'll know. Thallitic magmas are produced only at divergent plate boundaries. Alkaline magmas are produced only at convergent plate boundaries. Alkaline magmas are produced at convergent and within the plate settings. Thallitic magma are produced at divergent, convergent and within plate settings. Now, these two statements are about the thallitic magma. इधर वो सिर्फ एक divergent plate boundaries cover कर रहा है, इधर divergent, convergent and within plate setting. The statement which covers more fields has more tendency to be correct. So this will be incorrect. But I'll be discussing everything else with you. Don't you worry. Thallitic magma. Thallitic magma जो है एक कॉमन टाइप ऑफ बेसोल्टिक मैग्मा होता है. स्पेसिफिक टेक्टोनिक सेटिंग में होता है. डाइवर्जेंट, कन्वर्जेंट एंड विद इन प्लेट सेटिंग. SiO2 तो इसके अंदर कम से कम 42 to 50% होता ही होता है. लेट मी जस्ट जूम इन. या 42 से 52% तक तो होता ही है. Alkalis are low and it is dominated by plagioclase, feldspar, pyroxene, olivine, iron, titanium, magnetite, ilmenite, all are there. In trace elements, there is potassium, rubidium and thorium. And it is found in morb, it is found in hotspot, it is found in subduction zone. Okay, it is found everywhere else. And yeah, thallitic magma is like that. Now we have the calc alkaline magma. So calc alkaline magma is something that has SiO2 almost 56 to 70%. It has high LILE, high HRED. It is something that is present only at convergent plate boundaries, subduction zone, volcanic arcs पे, ठीक है. And it is commonly associated with continental thick crust, and it leads to more evolved calc-alkaline magmas that produce granodiorites and andesites. So why does calc-alkaline magma is associated with convergent plate margins and etc. So partial melting of mantle wedges it produced basaltic magma. जब मैग्मा राइज करता है सो वो ओवरलाइन क्रस्ट के साथ इंटरेक्ट करता है, इनकॉर्पोरेट करता है क्रिस्टल मटेरियल्स को, फिर कैल्क एल्कलाइन मैग्मा में इवॉल्व होता है थ्रू फ्रैक्शनल क्रिस्टलाइजेशन. ओके, नाउ alkaline magma are produced at convergent and within the plate tectonic setting. It has SiO2 less, NiO2K2 more. It has felspathoid, nepheline, lucite, alkali feldspar, cyanopyroxene, orthopyroxene, amphibole. Alkaline magmas are of two types, sodic rich and potassic rich. Okay, and the tectonic settings I already told you is there at the convergent and are produced within the convergent and within the plate settings. Within the plate settings. So within the plate setting, it's continental rift settings. Here the mantle upwelling occurs. There is a low degree of partial melting, that is enriched in mantle source, and the greater pressure and the depths of partial melting. So the all last these statements are correct. Okay. SiO2 I've told you thallitic में moderate to high, alkaline में low to moderate, and calc-alkaline में is high. Tectonic is mid-oceanic ridges, hotspot, and arcs in thallitic, like everywhere else. In alkaline, it's either convergent or it's interplate. In alkaline, it's either convergent or it's interplate. And in calc-alkaline, it's the subduction zone convergent boundaries only. Okay. With this 37 question is done. Now coming to the 38 question. एक अल्ट्रामैफिक रॉक है, वोल्केनिक रॉक है, यानी कि प्लूटोनिक नहीं है, वोल्केनिक है. दूसरी यहीं से आपकी होगी स्पिनिफिक टेक्सचर इसमें होता है. इनमें से वो क्या है? किम्बरलाइट. किम्बरलाइट क्या है? किम्बरलाइट एक इंट्रूसिव रॉक है. यहाँ पे डायमंड्स बनते हैं. अल्ट्रामैफिक है बट इंट्रूसिव है. मैग्नीशियम आयरन बहुत ज़्यादा है. ओलिविन, फ्लोगोपाइट, डाइप्साइट, स्पिनल, परवोस्काइट, गार्नेट. इट इज़ प्रेजेंट इन अ इंट्राप्लेट सेटिंग, दैट इज टेक्टोनिक सेटिंग. In bonanite is rare and excellent marker of initiation of the subduction zone. It is act as a marker for subduction zone. Why my writing is so bad yaar? Marker of subduction zone. and it's mafic to ultramafic rock, and it's high in magnesium and silica. It has orthopyroxene, cyanopyroxene, olivine, chrome spinel. Now we have the where it is present in the fore arc of the subduction zone, like just above the subduction zone it is present. And its formation, it requires unusually high temperature and high rest mantle during the early stage of the subduction. Now talking about the Herzbergite. Herzbergite is a residual mantle rock. When someone asks you, okay, what is residual mantle rock? In the previous paper we also had the question like this. So it's a residual mantle rock. It's something that is, depleted residue left behind after the partial melting of the mantle to form basaltic magmas. It has magnesium, iron, and SiO2, low SiO2. It has olivine, orthopyroxene, but no cyanopyroxene. And it is found in mid-ocean ridges, back arc basin, and subduction zone. Okay, so it's also done. Comatite is ultramafic, and it's formed at very, very high temperature, almost 1600 degrees Celsius, and it has specific texture that is a needle-like texture, and plate-like crystals olivine grow rapidly. It forms large elongate crystal in, crisscross pattern, and it is something that is prevalent in Archean times when Earth mantle was hotter, and formation is rare today of comatite. Now coming to the 39 question, a concordant lens shaped convex upward igneous intrusion है. So I've already told you in previous video. डोमलक, और कौन सा मैंने बताया था आपको? सॉसर लो. डोमलक यानी कि डोम शेप्ड लैकोलिथ. सो कॉन्कॉर्डेंट लेंस शेप्ड है. कन्वेक्स अपवर्ड इज दिस, सो इट्स नॉन एज लैकोलिथ. क्यूपोला फैकोलिथ सेल, ये क्या है? सो क्यूपोला एक स्मॉलर डोम है, एक छोटी सी डोम है on the, and it is something that is formed on the top of large intrusive body like, granitic plutons, and it's a part of larger intrusion. It's not like laccolith. Phacolith is igneous intrusion that is formed along the crest of the fold, anticline, syncline, etc. Still we know it's a tabular body that is, very parallel to the our bedding planes. Okay, now coming to the 40th question. Just a minute. Okay. The texture in basaltic rock where angular interstices, like suppose this is a figure. एक टेक्सचर है बेसाल्टिक रॉक में जिसके अंदर एंगुलर इंटरस्टाइसेस हैं between plagioclase are, occupied by pyroxene. So these all are the plagioclase and it is occupied by this interstices are occupied by pyroxene. So ये क्या है? इसको देख के ना बहुत लोग एक्साइटेड हो जाएंगे कि अरे प्लाजियोक्लेस और पायरोक्सिन का रिलेशन, इट मस्ट बी ऑफिटिक ही है. नो, there is a very minute difference in the statement. You need to catch it. How? So intergranular texture, something that is very common in basalt, and it occurs when small grains like pyroxene, they occupies the angular spaces present in the plagioclase crystal in basaltic or similar igneous rock. It is something that formed during the cooling of the magma and crystallization of the magma. In basalt, plagioclase is something that, crystallizes first. In plagioclase, something that crystallizes first, and they leave the gap that is present between them, and the gaps are later on filled by the pyroxene, which crystallizes afterwards. So as a result, the texture is occupied by the network of angular plagioclase grains surrounded by the smaller pyroxene. Now what about vitrophyric? Vitrophyric is when large phenocrysts are embedded in glassy, that is vitric means glass, in vitric matrix, that is example is obsidian. Now ophitic is what? Ophitic is large pyroxene grains. They are enclosed by small they are enclosing the small plagioclase slats, like pyroxene are enclosing the small plagioclase slats present in them. Here the pyroxene is occupying the interstices, that is angular spaces between here, and in here ophitic, the pyroxene is enclosing the plagioclase slats, and it is very typical in gabbro. Okay. Subophytic is something that pyroxene is partially surrounding. There is a partial incomplete reaction. Incomplete growth is there. Plagioclase lath, but not completely, encloses them. It's present in basalt and diabasis. Interclinar, I have already told you. Now coming to the 41, volcanic debris when mixes with sufficient water and produces mud flow is termed as what? Uh, Lahars is something that is present as a mud flow, and it moves around 60 kilometer per hour speed almost. It's a volcanic mud flow, and it's a very composed of mixture like ash, pumice, rock fragments, water, etc. Lahar is dense, fast moving, and destructive, and a volcanic eruption, loose ash, pyroclastic materials on slope, and intense rain is something that mobilizes debris, that is lahars. Now talking about the tuff, what actually tuff is a rock. It's not a mud flow, it's a rock, and it is formed by the compaction and lithification of volcanic ash and other pyroclastic materials. Ignimbrite is a pyroclastic rock, and it's formed by the deposition and welding of hot pyroclastic flows and consist of ash pumice. So during volcanic eruption, what happens is pyroclastic flows, they raise down the slopes of the volcano at high temperature, and when the flows settles in the bottom, the ash and pumice fragments, they all fuse together to form ignimbrite. Block and ash deposit risk a collapse of lava domes. So lahar is the right answer. Now coming to the 42nd question. In diapside, alvite, and orthite ternary diagram, there is this ternary diagram, a कर्व along which the both, एक कर्व की बात हो रही है यहाँ पे, तो कर्व और कर्व तो यहीं पे आपके शॉर्टलिस्ट हो गए. लाइन और यूटेक्टिक पहली बार हो गए. along which both diaps and plagioclase can coexist whenever there is a thing about coexisting. तो पिछला क्वेश्चन, पिछले PYQ का क्वेश्चन आप देखिए, वहाँ पे मैंने कैसे कोटेक्टिक, पेरिटेक्टिक कर्व, कोटेक्टिक पॉइंट, पेरिटेक्टिक, यूटेक्टिक, हर चीज़ के बारे में बताया. सो कोटेक्टिक कर्व क्या है? इट्स अ इक्विलिब्रियम बाउंड्री जहाँ पे दो सॉलिड्स और लिक्विड इक्विलिब्रियम में एग्जिस्ट करेंगे और साइमल्टेनियस क्रिस्टलाइजेशन होगी. जैसे कि डायप्साइड, एल्बाइट एंड ऑर्थर सिस्टम में कोटेक्टिक कर्व रिप्रेजेंट करता है डिफरेंट फेज फील्ड्स वेयर मल्टीपल फेजेस कोएग्जिस्ट इन equilibrium. Ternary eutectic is lowest temperature coexisting of three phases. Is a point in a ternary phase where three phases, they all coexist with liquid at lowest temperature where melting begins or crystallization ends. Tie line curve is something that connects 2 points, solid phases in phase diagram to show composition of these phases are in equilibrium. Peritectic line marks the boundary where solid phases reacts with liquid phases to produce different solid phases. So that is peritectic line. Now, coming to the 43rd question. In many dikes, phenocryst phase get concentrated towards the center of the dikes away from the wall due to which method? Flow segregation is a process which refers to the process where different phases in magma or flow, they get segregated or concentrated due to dynamics of flow during emplacement. So in dikes, phenocrysts are something that tends to accumulate in certain zone, especially in center due to variation in flow velocity and magma viscosity. Magma flows through dike flow near the walls is slower due to frictional resistance within the surrounding rock, and in central part, the velocity is higher and the lower friction. Magma mixing is a mixing of two magmas of different composition, that is hybrid magma, and it creates a disequilibrium texture. Vapor phase exhalution is something that happens when volatile component escape from the magma as it cools and pressure is dropped. Country rock assimilation is a process when magma melts and incorporate pieces into the surrounding rock. So country rock assimilation kind of get from the term कि country rocks में assimilation or vapor phase exhalution is something escaping of the gases or volatile thing from the magma mixing, two type of magma mixing. Flow segregation, something is getting segregated on the basis of frictional resistance and velocity as well as magma viscosity, flow velocity. So that is flow segregation. Now coming to the 44 question, which one of the following basalt type is depleted in the light rare earth element LRED में? ये basalt जो है depleted है. Continental thoracic basalt, alkali olivine, high, these all are the type of basalt. So LRED is something that includes lower atomic weight than HRED elements, and they are incompatible. They are preferentially partitioned into magma during melting. N-mob is something that is depleted in LRED. It is something that is formed at divergent plate boundaries and it undergoes partial melting. Due to partial melting and MRE, most of the LRR is, they get extracted very early and they get partitioned into melt, leaving behind a source. Continental thoracic basalt is continental rifting setting and it's enriched in mantle crystal components. Alkali olivine basalt is also enriched in air and it is an intraplate hotspot setting on continental rift zone. High potassic island arc basalt is there in the subduction. So yeah, the D option would be correct. Now coming to the 45th question, which one of the following pair minerals is formed by the carbon during phenatization? Again the question is on phenatization in this paper. So कौन से पेयर के मिनरल है जो phenatization से कार्बोनेटाइड के फॉर्म होते हैं? So phenatization is an intraplate tectonic setting or continental rift zone में. It's a metastomatism that occurs when alkaline fluids that interacts with country rock, especially carbonatites, and it promotes the formation of alkali-rich minerals, agrine, orthoclase, and microcline. It's sodic. Agrine is sodic-rich pyroxene and is potassic feldspar, and it is and this is potassic feldspar, and microcline is again there. So it's the dominance of alkali metal. Mineral assemblage is also there. Along with that, we have the rabicite, we have the orthoclase, we have the microcline, we have nepheline, felspathoid, hematite, magnetite. These all are the mineral assemblage we get. So agrine and orthoclase. Why plagic? Plagioclase is something that consists of calcium in it. So plagioclase is removed. Microcline and adurine. But the orthoclase is much more reliable. Yeah. Microcline is there, but in very minimum amount. Okay. Okay, coming to the why this is showing problem. Okay. 46th question. Granitic rock. It's a granitic rock that contains higher Al2O3. I have mica, garnet, cordierite plus normative corundum is termed as what? So, what is it was trying to say is कि okay, एक ग्रेनिटिक रॉक है, हायर Al2O3 है, हायर माइका, गार्नेट, कोडायराइट है और नॉर्मेटिव corundum है. तो ये क्या है? M type granitoid जो होते हैं, it's something that is derived from the mental source that was termed as M type, and it is associated with mental derived basaltic magma that differentiates into granitic composition. It has olivine and pyroxene, and it is present in oceanic and extensional tectonic settings. So it does not signify the fact that it is a granitic rock or something. Okay. I type granitoid is igneous source. That's why it's written volcanic convergent plate margins, and A type granitoid is anorogenic. It's a non-mountain building and it's present in rift zone and in hotspot. So with this, S type granitoids is orogenic zones. Sediments are deeply buried and partially melted. S is rocks derived from partial melting of sedimentary rock. It's either pelagic or aluminous. It has higher Al2O3 that is present of aluminous materials, that is garnet, muscovite, and cordierite. That is full of aluminium. Corundum forms when aluminous when the material is bit high in Al2O3 or alumina, and it is low in silica. So just remember that we have mica, garnet, and cordierite. They all are very high in Al2O3, and corundum वहीं पे exist करता है जहाँ पे alumina ज़्यादा हो. So that is S type. Now we have the following magma types. Again on the magma types and the settings. बोल रहे हैं high liquidus temperature है and mostly restricted to Archean time. I told you this already. It's the comatite only. So comatite is ultramafic rock and it is low SiO2 and it is high, magma. It's also a magma type, high magnesium oxide, and it has a temperature that is 1650, and liquidus is a temperature at which the magma begins to crystallize. It is present in Archean, that is around 2.5 billion years ago, and Archean greenstone belts are something that is associated with that. So it's a primitive mantle melt. Kimberlite is ultramafic rock, but it is high in volatile content, that is CO2 and H2O. And the liquidus temperature is somewhat bit low of 1200 to 1300 degrees Celsius, and it has intra-plate setting that is cratonic. We have continental alkaline. Alkaline magmas are rich in alkalis and silica undersaturated, and it has 1000 to 1200 liquidus temperature. It is present in continental rifts and hotspots. Okay. Ultra alkaline and silica poor alkaline. It's a felspathoid. Nepheline, around 1000 to 1200 degrees Celsius, and interplate extensional environment is the place where it is present. Now, coming to the 48th question, which one of the following basalt types is generated in within plate settings aided by mantle plume activity? Within the plate settings, and it is aided by the mantle plume activity, that is continental flood basalt only. Because it's a mantle plume activity, there is huge outpourings of basalt lava that covers the huge areas like Deccan traps. It has intraplate volcanic activity and plume induced drifting. Volcanic arc basalt is formed at convergent plate boundaries and in subduction zone. Morb is the divergent plate boundaries and it happens because of the decompression melting of the upper mantle. Island arc tholite is formed at subduction zone, that is on the convergent plate boundaries and subduction related geochemical signature. So can you feel one thing, that the questions that I have discussed, they are just revolving around something, almost 3 to 4 questions are revolving around in repetition. Like in this, we have से पूछ लिया कि continental flood basalts क्या है, कॉमाटाइट क्या है, किम्बरलाइट क्या है, कॉन्टिनेंटल अल्ट्रा एल्कलाइन कौन से होंगे, नेफेलिन होंगे, सिलिका पोर एल्कलाइन वही होंगे, कॉन्टिनेंटल एल्कलाइन आई हैव ऑलरेडी टोल्ड यू कि एक ऐसे मैग्मा जो कि एल्कलाइन एल्कलीज में रिच होंगे, कॉन्टिनेंटल रिप्स एंड हॉटस्पॉट में होंगे, किम्बरलाइट मैंने बता दिया कि अल्ट्रामैफिक है बट हाई वोलेटाइल कंटेंट है इनके अंदर एंड इट हैज़ अ टेम्परेचर दैट इज लो एंड इट इज प्रेजेंट इन क्रेटोनिक सेटिंग्स. Okay, I'm typing. So everything is getting a bit repeated. So with this I will end this video because there is some glitch in the okay. So thank you.